Hi, I'm Ruby Van Kerenberg, student ID 2540790. Today I'll demo my game Banana Runner and then walk you through the key parts of the code. So here I'll focus on version controlling, event-driven programming, interoperability, and visual identity. Okay, let me show you the app first. So to start off, this is the main page, menu page. As you can see, it shows the 3 levels and they activate dynamically as you play. So now to actually play, you need to have an account. So let me go ahead and register a test user. When you click register, you have a couple of options. You can manually create an account by filling out the form, or you can log in using Google or GitHub. I'm going to go ahead and use a Google account for this demo. Alright, so we are logged in now. Let me start a run. So you can pick whichever character you like, and I am going to go with the monkey here. So the goal is to collect bananas. I just hit by an obstacle. As you can see, whenever you hit an obstacle, the run pauses and a math puzzle pops up. If you answer correctly, the run continues. If you get it wrong, you lose a life. So I'll try a few random numbers here to continue. Since that's going to take a bit of time, I'm just going to give up and continue the demo. So as you keep hitting obstacles, you'll notice the lives count goes down up in the top corner. You can also see the timer and the total numbers of bananas you have collected so far. Okay, let me go to the leaderboard. This shows the saved scores from the previous runs, and it updates automatically after each run, so your latest scores would show up here. And over in the profile section, you can see all the user stats, achievements, and your preferred character. If you want to change something like the username or bio and update your avatar or change your password, you can do so, but I'm not gonna do anything here. So finally, when you are done, clicking logout clears the session and returns you to the login screen. Okay, now let me show you the code. So I built Banana Runner using React plus Vue client, React 3 Fiber for 3D rendering, and an Express node server with MongoDB. As for version controlling, I used GitHub and worked on weekly branches. Let me show you my recent commits and merge. So here we go. I use short focused branches for each feature and open pull request for code review, and that keeps changes small, reviewable, and easy to revert if something breaks. And for event-driven programming, I used a lightweight event bus. Let me go to the event.js file. As you can see here, it defines a game events class that stores listeners in this .events, and on event callback it registers a listener, and event data calls all listeners for that event, and off event callback removes a listener. And here in gameworld.jsx, on collision I pause the run and request a puzzle. So the code sets state and emits events like the UI, and so score system responds independently. And here in submit final score, after saving I emit score colon saved, so the leaderboard and profile fetch updated data. And as alternatives, I could have used Redux for global events, but Redux adds boilerplate and complexity, but a small event bus is low overhead and suits real-time gameplay. For the interoperability, the game fetches puzzles via getBanana question from banana service.js file, which calls API banana on our server. The server proxy uses banana API.js to call the third-party banana API, So this lets the server handle rate limits, credentials, and normalization. I could have called the client directly from the front end, but that risks exposing API URLs and keys, and it complicates calls and rate limiting. So I proxied it through this server, and I also used React 3 Fiber, and it lets me describe 3D scenes in JSX, which is the interoperability glue between React and Three.js. As an alternative, I could have used Babylon.js. Babylon.js is also very powerful, but it lacks the tight React integration that I wanted. So I used React 3 Fiber because it made component reuse and state syncing straightforward. So as for the virtual identity and authentication, my app uses OAuth providers, Google and GitHub, and server issued JWTs stored as HTTP only cookies. So that combination gives a smooth user experience and reasonable security. Let me go to my authcontext.jsx file. So on load, the client calls API auth me. So if the server returns 401, we fall back to cached local storage to avoid crashing UI during transient auth issues. And let me go to the OAuth controller.js. So here the server sets an HTTP only token cookie, so JavaScript can't read it. The server verifies JWTs for protected routes like saving scores. And here in auth.control.js file, API auth me returns user metadata and aggregates totals, so the client displays profile stats without recomputing them. So simply Google or GitHub confirm who you are, our server gives a secure ticket, and the browser sends that ticket automatically when calling protected APIs. So as for alternatives, I could have stored tokens in local storage, and it's easier for some clients but risky because malicious scripts can read tokens. And also I could have used server-side sessions, and it's also easier to revoke sessions, but we need storage like Redis and more server complexity. So yeah, that's all about the game. Thank you.